सो लेट्स हैव द आइडिया ऑफ द डिफरेंशिएशन फर्स्ट ऑफ ऑल कि डिफरेंशिएशन होता क्या है. तो इसके लिए मैं एक एग्जांपल लेता हूँ. लेट्स सपोज वी हैव एक्स एक्सिस एंड वाई एक्सिस लाइक दिस इज आवर वर्टिकल वाई एक्सिस एंड देन वी हैव ए हॉरिजॉन्टल एक्स एक्सिस and we are drawing a straight line. So straight line goes something like this. Okay, and हमारे पास में कोई एक पॉइंट है यहाँ पे, लेट्स कॉल इट एज x1. उसके corresponding वैल्यू इस स्ट्रेट लाइन पे आता है y1. फिर इसके नियर बाई एक और दूसरा पॉइंट है हमारे पास में x2 और उसके corresponding वैल्यू आता है y2. ओके, सो यहाँ पे हम एक क्वांटिटी डिफाइन करते हैं जो आप लोअर क्लासेस में पढ़ते हैं, जिसको हम स्लोप बोलते हैं. स्लोप इज डिफाइंड लाइक दिस. स्लोप इज द चेंज इन y डिवाइडेड बाय चेंज इन x. करेक्ट. ओके, और अदरवाइज चेंज इन y अगर हम यहाँ पे ले तो ये अपने पास में हो जाता है दिस इज y1 एंड दिस इज y2. सो दैट्स वाई द चेंज इन द y इज गोइंग टू बी y2 माइनस y1. ओके, सो इट गोज y2 minus y1 and divided by the change in the x is of course x2 minus x1. Same way, like if we calculate this total length between this and this is x2 and this is x1, so that's why this becomes x2 minus x1. so del x का वैल्यू हो गया x2 minus x1. तो ये अपने पास में स्लोप होता है एंड इस तरह हम इसको डिफाइन करते हैं. ओके, व्हाट इज द मीनिंग ऑफ द स्लोप? स्लोप इज आर रेट ऑफ चेंज ऑफ द y with respect to x. okay, if y is one variable, if there is y which depends on the x, then we'll call this relation as a function. So y is a function of x. Okay, then if we change x value, of course there will be a change in the y, and all the time there the change may not be same. Like for example, if I change in the x by 2, then change in the y may be something different. And to measure that relative change, we define a quantity called as slope. Okay, and slope is our rate of change of y or of one variable with respect to another variable. Okay, and if we go into the physics, of course instead of variable we will have the physical quantity. Like think about a situation where you are walking. So जब आप वॉक करते हैं तो आप कुछ एक डिस्टेंस कवर करते हैं जो टाइम के साथ में चेंज होगा. नाउ जब टाइम चेंज होता है तो डिस्टेंस में रिलेटिव चेंज डिफरेंट पर्सन के लिए डिफरेंट हो सकता है एंड उसको रिलेटिव चेंज को हम बोलते हैं स्पीड. तो रेट ऑफ चेंज ऑफ द डिस्टेंस विद रिस्पेक्ट टू टाइम वी कॉल इट एज स्पीड, एंड लाइकवाइज वी हैव द क्वांटिटी, वी डिनोट इट विद m. ओके, we denote it with m. If you look carefully, let's suppose if I say the angle of this straight line is theta, then this becomes theta, right? So then what is the slope? Slope is actually, if you look in this triangle, let me just point it out. So I have this triangle. In this triangle, if I take the slope is this divided by this, which is also the tan theta, isn't it? So I can say that this is also the tan theta. Okay, then why I'm explaining about the slope? The reason is I'm coming on the differentiation. Now think about the situation where we don't have a function like a straight line. I have taken here a graph like a straight line between the y and x. It is always not necessary that you will have a straight line, so the graph can be something different. So think about a scenario where you have a graph kind of a curve. Now what is curve? Curve is like a part of circle. Okay, so the change in the y goes something like that. Now if you look at this, let's suppose this is okay, let me take here. So this is, let's suppose, x1. Corresponding to that I have y1. Okay, and then there is x2, and on this curve the value comes out to be y2. Okay, this is x-axis and y-axis. Now you look at this. If you calculate here the delta y divided by delta x, the delta y divided by delta x will be, of course, you can say y2 minus y1 divided by x2 minus x1. Now if you look at this graph, so then every point, if you look, let's suppose this point the x is changing and the change in the y is very low. But if you look at this, if there is a slight change in the x, then the change in the y is more. How do I say? Because if you look at the graph, you can easily say that. So from here you understand that the rate of change of y with respect to x is not constant. ठीक. So y x के साथ में रेट y x के साथ में सेम रेट से चेंज नहीं हो रहा है हर जगह. तो यहाँ पे जो हम डिफाइन कर रहे हैं ये डेल्टा y डिवाइडेड बाई डेल्टा x, इसको हम बोलेंगे एवरेज रेट. ओके, दिस इज आवर average rate of change of y with respect to x. Rate of change. Now in the average rate of change, if I draw a line like this, connect these points, then I look at this line, then this line becomes a chord of this curve. You remember chord is a line which is passing from the 2 points of a circle. So this is the chord. So basically you can say that average rate of change is actually the, if I take theta, then I can say that this is tan theta. So can I say that average rate of change is actually the chord of the slope of the chord. Slope of chord. Now when there is a person, think about a situation where there is a person, he is walking. Now each time he is not walking with the same rate. So then in the duration of time, of course, you can find out the average rate of change, and from there you can define that ये इसका average speed है. Okay, but किसी point पे अगर आपको मैं पूछूँ like for example कि t equals to 10 seconds पे उसका speed क्या है, तो कैसे बताएंगे? t equals to 10 second पे exactly मैं पूछ रहा हूँ कि t equals to 10 second पे उसका speed क्या है, that will be called as the rate of change at that instant. Okay, like for example, instead of calculating x1 and x2 in between x1 and x2 for this much duration, I want to ask you exactly what if there is a random point x, at this x point what is the rate of change. So to calculate that, what you are going to do is you will take a small change nearby x, corresponding to that you will have a small change in y, and then with the help of that you will say that del y divided by del x is the rate of change at that instant. Okay, let's understand in the graph this again. So I was saying that let's take a graph which is curve. Okay, ये अपना कर्व हो गया. एंड नाउ यहाँ पे जस्ट विजुअलाइजेशन के लिए मैं थोड़ा सा डिफरेंस को ज़्यादा ले लेता हूँ. ये जो डेल्टा एक्स है वो बहुत स्मॉल है, एंड व्हेन देयर इज ए स्मॉल चेंज इट विल बी डिनोटेड डेल्टा एक्स इज टेंडिंग टू 0, so it will be denoted by dx. So what is the change? This small change we'll call it as dx. Corresponding that will have a change in the y. This is our dy. Okay, and the ratio of that will give us the rate of change of y with respect to x at that point. So let's find out that. That is dy by dx. This is the rate of change of y with respect to x at that point. Okay, or if there is time then we can say at that instant. Okay, if we zoom it like this, then and if we connect this point like this, okay, we'll have a straight line going like this somewhere. Okay, you assume it like it is just touching this point. So then you have a change in the x. This is the change in the x and this is the change in y. So there is dx and then there is dy. Okay, then if you take the ratio, then does it become the again tan theta here, because this is a small triangle and this is angle theta. Okay, so then also it becomes tan theta. So this is also tan theta, but if you look, this is the theta for this straight line, and this straight line is not the chord, it is the tangent. Okay, so what I can say is the rate of change of y with respect to x at that point, the graphically meaning of this is that this is the slope of tangent of curve at that point. Okay, now let's come to differentiation. So what is the differentiation? So differentiation is defined like this. Differentiation is the rate of change of one quantity with respect to another quantity at particular point. And so differentiation, it is our rate of change of y with respect to x at some point. And the graphical meaning of course this differentiation is going to be, it is slope of the tangent. So of course you must have understood what is the meaning of the differentiation. Now next point is, how do we get the differentiation? Like let's suppose there is some relation y equals to 2x plus 3 or y equals to x square. Then how do we get the differentiation? So for that we have some differential formulas that you need to memorize. Like you will study them in the mathematics when you will cover the calculus, of course there. So this course where we are just covering the introductory part of these tools, okay, which are sufficient for you to do the calculation in the physics. But of course if you need more complex calculation, then you need to refer the mathematics lectures. Okay, so here I am directly writing down the differential formulas. Okay, so these formula of differentiation you need to memorize. Like you have memorized some of the formula. Like if I remind you, you must know the sine theta. Sine theta is opposite divided by hypotenuse. Like this, you must have also memorized sine square theta plus cos square theta equals to 1, and then a plus b whole square. Likewise, for the differentiation also we have formulas. So, and you can also understand them logically, and in the mathematics of course you will also have the derivations for them. So d by dx, differentiation of any constant, think about it, what it will be. Of course it will be 0, because constant does not change with respect to any variable. Okay, it will not change, so that's why differentiation of any constant is 0. Then d by dx of x to the power n, where n can be any value, like for example 2, 3, minus 2.5 or anything. So then the differentiation is going to be n times of x to the power n minus 1. Okay, then the differentiation of d by dx